Welcome back to Understanding Python. My name is Jake, and today I'll be teaching you how to read from and write to files. File input and output is an essential skill for Python programmers. Having a strong understanding of this subject will allow you to work with persistent data and interact with your file system. As we go, if you learned something new, let me know by liking the video. Now, let's get started. Working with files in Python is pretty easy, and the main way that we're going to do that is by using the built-in function open. And this is going to take a couple of arguments. The first thing is going to be the path to the file that we're wanting to open. On the right, you'll see I have a file in this directory called names.txt. I can simply put names.txt as the argument, and that's going to be a string. You can either pass in an absolute or relative path to where your file is located. For example, if this file was in a subdirectory called files, I'd put files/names. Or if it's one up from where I'm currently at, I'd put 2 dots. But since this is in the current directory, I can leave it as is. And what the open function is going to return is a file handler object. We'll store that to a new variable called namesFile and set that equal to the result of calling open. So after this line runs, Python will open the file and then give us control of that through this namesFile variable. And since this is the manual way of opening a file, you'll always want to make sure that you close the file out when you're done with it. If you're doing things manually like this, get in the habit of closing it out as soon as you write the statement to open it. And then you can fill in the code that you want in between later. This way you never forget to close it out. Closing effectively writes the changes to the file, and Python then releases control of the file. Now there are a number of different things that you can do with this file handler object, and a few properties that you can access as well. The first I will show is you can access the name of the file itself. We obviously know that it's called names.txt because we explicitly pass that in. But if you're programmatically generating names or iterating through a number of possible names in a list, you can use the .name attribute from namesFile to get its actual name. That way you know what you're working with. And we'll print this out. So if I run this now after saving and making sure I'm in the right directory, we'll run this and we'll see file name is names.txt. Well, that's not very exciting yet, as we're more interested in the contents of the file. Well, there are a few main ways to get the contents of a file once you have this file handler object. The first is going to be the read method. So we'll store the results of the read method in a variable called allNames. And for that, we'll say namesFile.read. The read method can take a single argument, and that is size. It expects an integer as the size. For text or ASCII files like this, the size will be the number of characters you want it to read. If you don't pass in a specific size, then it'll read everything at once, which is why the variable is called allNames. We'll get more into passing a specific size later on in the video, but for now, we're going to read everything. And after we've read everything, we're going to print allNames. Let's give ourselves a little bit more room, save it, and run it. And here again, we see file name is names.txt, and then we have all the contents of that file, exactly what you see on the right. Now there's another point to be made about reading things in manually like this, and the effect of calling read, which I'll demonstrate now. We're going to print reading more lines. And after that, we're going to print the result calling namesFile.readLine. Now the difference between read and readLine is that readLine will go to the end of a particular line. So while you may not see it here, in the file, there's actually a new line character at the end of each of these lines, which lets the file know when it should break the text up. Python looks for that new line character to determine when a line should end. So readLine is going to read until it finds the end of the line, or that new line character, and then stop. We'll do this 2 times. We'll save it and run it. But what's going on down here? We see reading more lines, and then we have 2 blank lines. Well, that's because when you read something in a file, Python keeps track of your position. So when we read everything with no size specified, Python read the entire file. So at that point, it is at the end of the file. So when we tried to read 2 more lines, it had nowhere else to go. And as a result, it gave us nothing back. To further demonstrate, we're going to say print namesFile.readLine or end of file. And we'll do that for the second one as well. And now we see our 2 lines down here say end of file, because nothing was returned by readLine. More accurately, nothing truthy was returned because it returned an empty string. Now before we dig into that a bit further, there's another nifty attribute from files you can check just to make sure you have everything cleaned up. And that's a check to see if the file is closed. And that's simply namesFile.closed. It's an attribute and not a method call. So if we run this, at the end we see file closed true. Okay, let's take a closer look in IPython. We'll do the same exact thing as we did before. NamesFile is equal to open. It's going to be names.text. And now we have namesFile. And namesFile is technically a text IO wrapper, or a file handler object. In its attributes at the top we see its name is names.text. The mode that it's in is R, more on that later. And then we can also see the text encoding as well. Earlier we stored all the names in the file in a variable called allNames. And we did that by calling read on namesFile. And now we see exactly what that namesFile looks like. Instead of having the line breaks as printed out before, remember how I said there's actually a new line character at the end of each of these? Well, we can see that in Python. Jake, and then the /n. That's the new line character. Same thing after Amanda, Kiara, all the way until the end. When you perform a straight up read like that, all the new line characters are preserved in the text that you get back. Alright, getting out of IPython, we'll title this section Manual, Open, and Close. Now if you don't like having everything jumbled into a single string with the new line characters in place, you can use another method of that file handler. So we'll do the same setup as we did before. NamesFile is equal to open names.text, and this time we're still going to use allNames, but allNames will actually be the result of readLines. And what readLines is going to do is it's going to give us back a list, and where it's going to separate the elements of that list is on those new line characters. So the elements of the list I'm expecting out of this call would be Jake, Amanda, Kiara, Vanellope, etc., each an individual element of the list. So we can print that out first. And let's actually make that a little bit nicer with an F string. And then we'll also print out that we're printing out one at a time. And just like all normal iterables like lists, we can simply do for name in allNames print name, and then make sure that we close this file. And here we should be good to go. So we'll save it and run that. Oh, look at this. First we see where we started, allNames, and here we see the list, Jake, Amanda, Kiara, etc., all the way to the very end. And then we see printing out one at a time, Jake, and then an extra new line there. Same thing all the way down to the end. Why are we getting that extra new line? Well, 2 things are going on here. One, you'll see that we have a new line character at the end of this. So while it splits on the new line, it does include that new line at the end of each element. And another thing is that the print statement by default ends with a new line character. Luckily, this is a behavior we can change. So where we have print name here, if we add a comma, we see that we can also put end. And here, we're going to end it simply with an empty string. So we're telling it to, instead of put a new line at the end, put nothing at the end, because we already have a new line. So we've saved and ran that, and now that looks much better. Printing one at a time, Jake, all the way through Hunter, and then Horace. We'll title this section, Read All Lines into a List. Alright, so you're getting the hang of using open and close on files, but you don't really feel like having to open and close that manually every single time. This is where some Python magic comes into play, and that magic is in the form of what's known as a context manager. So I'll show you what this looks like, and then explain exactly what's going on. With open, same thing, names.text, as names file, and then you see we have an indentation here. We'll print reading 3 names, and then print again names file dot read line. We know this is also going to include that extra new line character, so again we'll end with an empty string. Since we want to do this 3 times, we'll do that now. Alright, what's going on here? What is this with keyword and as keyword? When you see with and as in Python, that means you're working with what's known as a context manager. A context manager handles some kind of process and gives you back an object as a result. While you're inside the scope of this context manager, you can do things with that particular object. And then when you exit the scope of that context manager, say here, the context manager will do some type of step to clean that up. For open, this top line is going to open the file just as before, as we did on line 17, and give us that file handler object stored in a variable called namesFile. We can then use namesFile within that context manager. And instead of having to manually close it out, once we're outside of the scope of the context manager, namely this with block, it's going to close it out for you. So if you use this context manager version, which is the recommended way of dealing with files in Python, you don't have to worry about closing files out manually. This relieves that burden of accidentally leaving a file handler object live. Let's save that and run it. And here we see the result. We have our 3 lines. But something kind of nasty here at this top. You'll notice that there's no separation between Horace and reading 3 names. And the reason behind that is because in the file, there is no new line character after Horace. The file just ends at the S character. If we simply hit enter, we'll add that new line character. And if we save and run this again, we now have that separation there. Perfect. So with our context manager, we have reading 3 names, then we have those 3 names, each as a result of calling readLine. Remember that when we read before, Python remembered the position that we were at. So after it read the first line, it knew that it was at the end of the first line. So advancing from the end of the first line, it has the second line, and then the third line. This way you're not reading the same thing over and over again. We'll call this little section Introducing the Context Manager. But it gets even more simple than this. We don't have to manually call readLine for each line that we want to go through. In fact, again, we'll use this Open Context Manager, opening good old names.txt as names file. We'll print that we're going to read all names, and then we're going to say for name in names file, print name, and again we're going to end with an empty string, and then exit the context manager. This shows you how neat that file handler that was stored in names file is, because it'll also let you iterate over that file. When we say for name in names file, we're effectively saying for line in names file, because each time we go through that for loop, it's going to read another line, just like we did before. The difference being that it's going to keep going until it reaches the end of the file, and we never had to call readLine manually. Let's run that. And here we see reading all names, and then Jake through Horace. Beautiful. If I didn't have this print statement here, this would take just 3 lines of code. Not only that, but this is incredibly memory efficient because it doesn't load the contents of the file all at once, like we did with read. It's just going line by line, or new line character by new line character. So you can have a massive file and read through it incredibly efficiently. We'll call this section Iterate Line by Line. Alright, aside from just reading from files, we have a few other modes available to us. We use W for writing, A for appending, meaning instead of starting at the beginning of the file, Python will go to the end of the file. We can also put a plus after R to both read and write to files. And how do we specify that? Well, after we passed in names.txt, which is the location of a file we're wanting to read earlier, we could have also passed in an R for read. If you're just reading like this, you don't have to pass in the R because that's the default value. However, if you want to write to a file, you're going to want to pass in a W. So here, we'll open up a new file, literally called newfile.txt. We'll go ahead and put a little underscore as well. And after newfile.txt, the mode that we're going to pass in is W for write. And we're going to store that in a new variable called NF. So that NF will become our file handler object. Now, one thing to be careful of if you're using the W for write is that if that file exists, it's going to erase the contents of that file. So for example, let's go ahead and put some stuff in here now. Am I still here? And the file we're going to save this to is newfile.txt, matching the one we're wanting to write to in just a few minutes, and we'll save it. Now back in our Python code, I'll show you how to write to a file manually, and for that we're going to use the write function, nf.write. And in here, we're going to pass in a string, and we'll do this a couple of times. These lines, nf.write, are not separated, nf.write, and we're going to put a new line character here. Use new lines to separate. And let's save this. Now, as I run this, pay careful attention to what's going on in the right here. And since we are just straight up writing to the file, we're going to get our answer. Here we go. And there it is. Our question of am I still here has just been answered. And that answer is no. We open the file in write mode, which means that everything that was in it is now gone. Luckily for us, that's nothing we actually cared about. And now also look at the behavior on the right. We wrote to the file 3 different times. A lot of people, when they're starting out, expect these to be written to different lines. But that isn't the case, as we're not actually writing new line characters to those lines. It's not until we manually put those new line characters in our strings that they show up in the file. You can see that new line character implicitly here, as well as at the end, which is why we have this extra line here. Now, not only can we write just from a single string, you can also use the write_lines method. And write_lines will write more than one string. And what I mean by that, well, write_lines expects an iterable, like a list, and the contents of that iterable should be strings. And what it'll do is it'll go through the iterable and write each of the values to the file. So let's demonstrate this. nf.write_lines. And in here, I just want to have the numbers 0 through 5. But remember that I said it still expects it to be a string. Well, we can easily do that using the map function. So we're going to convert each of those values into a string. If you're confused about how this works, there should be a link in the top right now pointing you to my video on map and filter. Give that a watch, as these functions are also very valuable. We'll see what this looks like. And that's correct, I did say I wanted to go 0 through 5, so we'll bump range up to 6. As if you remember, range's endpoint is not inclusive. We'll try that again. And here we go, 0 through 5. That's all well and good. However, you still need new line characters. And for that, we can just modify that map that we did above. So instead of straight up mapping a string, we'll throw in a lambda function. That's going to take an S and return an F string, throwing in the value of S, followed by a new line character. We'll save and run that. And here you see, you still need new line characters. And then each of those is also separated by a new line character. We'll title this section, Writing to Files. Notice that each time that we did that, it overwrote the contents of this file. If you don't want that behavior, if you want it to start at the very end of the file, you would switch this mode up to appending with an A here. If we run that now, you see that it added that to the end of this. And it'll keep doing that each time you run this, adding it to the very end of the file, not overwriting the data you did before. This is something that you'll commonly see in loggers, always writing to the end of the file. If we switch that back to our W, then it's going to overwrite all those contents again, and we're back at where we were. Okay, up until now, all files have been opened in what's called text mode. That means we read and write strings from and to the files. But there's another mode we can use, binary mode. To do that, we add B to the mode. Now when we do this, data will be read and written in the form of bytes object. This is the mode you should use for all files that don't contain text, or shouldn't be interpreted as text. And that looks like this. Again, we're going to use the context manager. We'll call this file binary file. We're not going to put an extension. And the mode we're going to use is WB. It's WB because we still want to be in writing mode, but we also want to be in binary mode. Notice how these are additive. You could do the same thing if you wanted to read in binary mode and append in binary mode. We'll stick with W for now, and we're going to have this be B file or binary file. And similar to what we did before, we'll also use the write method. This time, instead of a normal string being passed in, we're going to put a B in front of it. That tells Python that this should be a bytes type string. And before I make a silly mistake, let's make sure we separate those arguments with a comma, so it doesn't combine them together. Now, if we look in our directory, we should have a new file called binary file. Let's move that over to our right. And here we see 0 through 9. I'm not going to use anything different than normal type characters, because that's a little bit harder to follow. So far, straightforward. Now let's write a little bit more to the file. bfile.write. Again, this is going to be a byte string. We're just going to do query UEOP. But this time, we're interested in how many bytes were written. So we can store that in a new variable called bytes written, which is what write gives back. So while it does carry out the write here, it'll also tell us how many bytes it wrote in the process. And we can print that out. We wrote bytes written, bytes to bfile.name. And we'll toss a cheery exclamation point at the end. So let's run this. And here we see it add QWERTY UEOP to the end. And we see it says we wrote 10 bytes to binary file. 10 is exactly what we were expecting, as that is the length of QWERTY UEOP. Alright, that wasn't so hard. So we'll call this section Working with Binary Files. And now that we have this binary file, let's play around with it a bit more in IPython. Give ourselves a bit of room, and we're going to go ahead and open that up. Since we're just going to be exploring within IPython, we can go ahead and use bad variable practices and just call this F. F for file. we're going to be opening up binary file. And this time, we're going to be reading in bytes mode, but we also want to be able to write to it. So we're going to put a plus there. This means that not only can we read from the file, we can also write to it. And this has the very nice side effect of not instantly overwriting the contents of our file. Now remember before when I said that read has a size that you can pass in, or how much you want to read at that particular moment. We'll try that out now. We're going to read 5. We get a byte style string with 5 characters in there. And if you also remember, our file handler object keeps track of our position after we do reads like this, so we don't have to start from scratch each time. Well, one of the helpful methods of that file handler object is telling us where we're at. And does that with the tell method. You see that we read 5 bytes, so now we're 5 bytes in. If we read another 5 bytes, we see that we're now 10 bytes in. But not only can we read in this way, we can also jump ahead. For that, we're going to use the seek method. And here we're going to say seek 15. And it tells us our position is 15. Now, we're just going to read a single character to let us know where we're at when we look at the file. And here we can see 15 in is Y. As you might have expected, that also advanced us to the 16th position. Now, not only can we seek forward, but we can also seek backwards. And we'll do that by passing in -5. But we want to make sure that the second argument that we pass in is a 1, because 1 stands for our current position. There's 3 possible values you can give for the second argument. 0, which is the default, references the beginning of the file. 1, which is what we're going to use here, is your current position within the file. And you can also pass in a 2, which represents the end of the file. So with this seek, we're saying move back 5 bytes from our current position. And you see it tells us that we're currently at position 11. And if we read a single byte from that, we see that we're now at W. And of course, because we read that, we also move forward that 1 spot. Now instead of going from our current position, let's try from the end of the file and see where we end up. Okay. This makes sense. Since our file is 20 bytes long, if we move back 5 from the end, we're currently at position 15. If you might remember from before, position 15 is Y. Now at this point, you now know how to navigate manually around a file, using seek and read and tell to figure out where you're at and move to particular locations. You can do this programmatically, reading certain contents at a time and deciding where you want to go from there. Additionally, we can also write to that file. Here I'm going to write a byte string that just says my name, and it tells us that it wrote 4 bytes. But notice that nothing changed in the file. That's because that doesn't change until that file is closed or flushed. Let's demonstrate on the close. Close the file, and now we see Jake at the end there. We manually overwrite this, finish off the query UEOP, open the file back up. We can do our seek again, f.seek. This time we'll seek -3 from the end of the file. We're currently at position 17, and then we're going to write Jake again. And instead of having to close the file to see the changes, we're going to call flush, which basically says all the changes I've made to the file handler object, go ahead and make to the file. And here, we still have the file opened. You see that f.closed is false, but the changes are now reflected in the file itself. So let's close that now. Now we've closed out the file. We can verify it's closed by calling closed again, and we see that we in fact have closed out the file. Speaking of closing out the file, that closes out this video. Now that you understand file input and output, you can apply this in countless ways. What is your favorite trick when working with files? Or was it something I showed today? leave a comment down below to let me know. As always, today's code will be added to the Understanding GitHub repo, so check the description for a link. And of course, if you have any questions or suggestions for topics you'd like me to cover, leave a comment for me. To keep up with this series, please consider subscribing. Thanks for watching.